With this video short, I'm going to talk about some of the differences between compounds, elements, and mixtures. Okay? So matter is anything that takes up space and has mass. So when we're looking at anything around us, we can identify that type of matter as either a compound, an element, or a mixture of something. Mixtures are pretty easy to think about and come up with. A lot of things around us tend to be mixtures. So things that we eat and drink are mixtures, right? If I grab a Gatorade, that's a mixture, right? If I grab salad dressing, it's a mixture, right? It's got oil and vinegar and spices and maybe a little bit of like Dijon mustard in it, something to help emulsify or blend up the oil and water. Anyways, side topic. Other mixtures around us, a lot of the foods that we eat, those are mixtures of different things, right? It's not like a pure substance. Things that are examples of pure substances are the elements. So you could have pure hydrogen gas, pure helium gas filling up an air balloon. You could have pure rock of some of the different metals that are on the periodic table. So you could have a gold, silver, maybe some of you have jewelry, right? That's a pure substance, pure gold, pure silver. Or it could also, you can have pure substances that are compounds. So the difference between an element and a compound is elements are the same atom, okay, and compounds tend to be different atoms or have at least two or more atoms associated with a compound. Elements are only going to be single individual atoms. And it gets a little murky here because certain compounds can actually be elements. So there are 7 diatomic elements, and it's Brinkelhoff, B-R-I-N-C-L-H-O-F. B-R for bromine, I for iodine, Cl for chlorine, H for hydrogen, O for oxygen, F for fluorine. N for nitrogen was in there. Brinkelhoff, B-R-I-N-C-L-H-O-F. It's on the next slide, or one of the slides in the PowerPoint. So Brinkelhoff are the 7 diatomic. That means there's 2 atoms for every 1 molecule of that element, and those are compounds. They're technically considered compounds because there's at least 2 atoms. There's also a tetraatomic element, that would be your sulfur, and then there's an octaatomic element, which is phosphorus. Okay, so all the other elements on the periodic table except those 9 are only single atoms, so they're all elemental. Okay. Other types of pure substance compounds, though, that aren't related to elements would be things like sugar at your house, glucose, fructose, a pure amino acid, just anything you can grab off the shelf in the chemistry lab is a pure substance. So, yeah, so that kind of helps kind of differentiate between mixtures and pure substances, and then talking about elements and compounds. So remember, element is only a single monatomic element. There's 117 so far elements on the periodic table. 9 of them are technically compounds. So in the whole periodic table, there is, what is that? Then 108 total elements that are just monotopic. There's 9 that are compounds, right? Diatomic, tetraatomic, and octaatomic. And then a lot of the other stuff we think about, water, H2O, that's a compound. Glucose, that's a compound. So we'll just leave it there. When we talk about mixtures of things, we can have 2 types of mixtures. We can have either heterogeneous or homogeneous. Heterogeneous mixtures have an uneven distribution of things within the mixture. So the best and easiest example to think of there is something like oil and vinegar in a salad dressing. If you get the balsamic oil and vinegar, they don't mix and they're not evenly distributed around. So oils is not everywhere that there's the water is at. Another example of a heterogeneous mixture would be if you pick up kind of a rock off the ground and you look at that rock, it probably has some areas that are white, some that are gray, and maybe a speck of green or red or, you know, auburn color here or there. So that would be an uneven distribution of the chemicals throughout the mixture. A homogeneous mixture, on the other hand, has an even distribution of compounds throughout the mixture. So homogeneous would be like if I had a glass of water and poured some salt and poured some sugar into it, I would have a really gross drink, but it would be a homogeneous mixture because all the salt would be dissolved, all the sugar would be dissolved, and you would just hold up your glass and it would just still be this colorless glass of liquid. Another example of homogeneous mixture would be like a Gatorade. That's the example that the book gives you. So, you know, you grab a Gatorade and it's all the same color throughout and it's all the same, you know, transparency throughout. So there's an even distribution of all the different compounds in the Gatorade throughout the whole thing. So hopefully with this video that helped kind of explain the difference between compound, element, and a mixture, and the two different types of mixtures, which are going to be heterogeneous or homogeneous.